Hi, in this video I'm going to talk about blockchain as workflow. Our content is nodes, blockchain as workflow, blockchain forks, and types of blockchain transactions. So let us talk about nodes. In a blockchain network, nodes are computers or devices that help maintain the distributed ledger and ensure network integrity. They verify and record transactions and ensure blockchain security. Nodes help decentralize the blockchain and make it resistant to tampering or censorship by participating in the network and working together to validate and record new transactions, ensuring the accuracy and up-to-date status of the distributed ledger. Let us also talk about node types. The first one is full nodes. Full nodes have a complete copy of the blockchain and are responsible for validating new transactions and blocks. They play a crucial role in maintaining the integrity of the blockchain. Lightweight nodes. Lightweight nodes are also known as simplified payment verification nodes and do not have a complete copy of the blockchain. Instead, they rely on full nodes to provide them with the necessary information to verify transactions. Mining nodes. In a proof-of-work blockchain like Bitcoin, mining nodes are responsible for solving complex mathematical problems in order to create new blocks and earn rewards. Validator nodes. Validator nodes are responsible for creating new blocks on the BNB smart chain. They are selected through a process called bonding, in which users can stake their tokens to become eligible to participate as a validator. We'll talk about these nodes in detail in part 3. So how are transactions executed? A wallet stores keys and enables the sending and receiving of digital currency. When you send a transaction, your wallet connects to a node and broadcasts the transaction. The transaction is added to the blockchain once it's verified. So I will talk about wallets in detail. For now, you just need to know that it is a storage that can store your keys and enables sending and receiving digital currency. I will get into detail in later lectures. So the node that a transaction is connected to helps ensure the security and integrity of the blockchain by recording the transaction and making it available to other nodes. Okay, someone requests a transaction in this regard. Then this request transaction is broadcast over a peer-to-peer network of computers called nodes. Then there should be a validation process, and this transaction can be a cryptocurrency, a smart contract, or any type of records. After a transaction has been verified, it is added to a group of other transactions to form a new block. So meaning that in a block we can have more than one transactions, not only one. Then the new block containing the verified transaction is permanently added to existing blockchain and cannot be altered. And we call that, okay, the transaction is complete. It's cool, but where do we store these transactions until they are picked by some of the miners? In this regard, we need to understand transaction pool. Transactions broadcast to the blockchain are temporarily stored in the transaction pool, also known as the memory pool or mempool. This is a collection of unconfirmed transactions waiting to be included in the next block. When a transaction is broadcast to the network, nodes receive it and place it in the transaction pool. It will then wait until a miner selects it to be included in the next block. Once a transaction is included in a block and the block is added to the blockchain, the transaction is considered confirmed. So here, we want to do a transaction using our wallet and add it to blockchain. To be able to do that, we first need to add it to transaction pool. Then some miners will take it and mine it and add it to blockchain, and all the nodes will be informed about this process. So let us understand mining. Transactions in a blockchain network are temporarily stored in the transaction pool until they are added to a block by miners. When a block is successfully mined, it is broadcast to the network and added to the blockchain if it's deemed valid. This helps ensure the integrity and the security of the blockchain. So we have a transaction pool and there are a lot of transactions here waiting for a miner. Then some of the miners will try to get the right nonce value. Then the block will be broadcast to all nodes after the valid nonce value was found. Okay, now we have a blockchain and the block will be broadcasted to all nodes. Here what we are trying to do, we are actually adding a new block to the blockchain, and miners will start to work on the last block which was added. Okay, let us talk about blockchain forks. We will start with temporary fork. A temporary fork may occur when two valid hash values or two similar hash values are obtained simultaneously. This can happen when two miners simultaneously solve the proof of work puzzle and create competing blocks. The network resolves a fork by choosing the longest chain, which is assumed to represent the most work and be the most trustworthy, and discarding the other one. This ensures that only valid blocks are added to the blockchain and helps to maintain its integrity and security. Here we have a fork here. We have another fork here. We assume that the longest chain is the valid chain, and we are just discarding these other chains. Hard fork. A hard fork is an upgrade to a blockchain network that creates a new blockchain with different rules from the original. It can happen when there is a disagreement within the network or a desire to introduce new features to the network. During a hard fork, the network splits into two separate blockchain networks, the original network and the new network. Each network has its own set of rules and operates independently of the other. Here, for example, we want a hard for a new blockchain, and there are some new rules. We are just making it another blockchain, and this blockchain will also continue with its own rules as well. Soft fork. A soft fork is a backwards compatible update to a blockchain network. It is used to introduce new features or make minor changes to the network. It does not result in the creation of a separate incompatible blockchain. Nodes that have not yet upgraded can still participate in the network during a soft fork. Here, there can be new rules added on old rules, and we are basically going backward and doing it on this blockchain. All right. So type of blockchain transactions. Let us start with public transactions. Public transactions are stored in the transactions pool for a while and wait for the confirmation. Here, when we do a transaction, it's going into transaction pool and wait for the miners to be selected. Then the miner will get the transaction and validate it. But when it comes to private transactions, they are sent directly to the miner or validator without being stored in the transaction pool. Here is the example. There is no transaction pool logic here. We are directly sending this transaction to miners, validators. So that's gonna do it for this video. I will see you in the next one.